determine whether the series is convergence or divergence. So the series you can see right here, we have to first check all the conditions for the test. So for the test, f of x to the 7 power, e to the negative x to the 8 power. This function has to be continuous, positive, and decreasing. You can see this function is continuous. It's a polynomial. Now it's positive. We can look at the function and we can tell it's positive, right? Now the problem is we have the interval from 1 to infinity. So on this interval, the function is continuous. The function is positive. Now for decreasing, we're going to take a look at the f prime. Okay, so f prime is going to give us, I'm going to use the product rule. So it's going to be x to the 7 power e to the negative x to the 8 power multiplied by negative 8x to the 7 plus e to the negative x to the 8 power times 7x to the 6 power. Let's rewrite. So if I factor x to the 6 power e to the negative x to the 8 power out, I will end up with negative 8x, negative 8x to the 8 plus 7. I'm going to rewrite one more time. So we have x to the 6th power multiplied by 7 minus 8, x to the 8th power over e to the x to the 8th power. So you can see this one is going to be negative for x greater than 1. I'm talking about this interval right here. Okay, since f prime is negative, we know the function is decreasing. So we good now. We're going to proceed with the interval. I have the interval from 1 to infinity, x to the 7 power, e to the negative x to the 8 power, d of x. Give us the limit. T goes to infinity, 1 to the t, x to the 7, e to the negative x to the 8 power, dx. Now let's take the limit as t goes to infinity. So using u substitution, I ended up with negative 1 over 8 e to the negative x to the 8 power, evaluating from 1 to t. I can definitely take out the negative 1, 8. I ended up with the limit as t goes to infinity, e to the negative t to the 8 power minus e to the negative first power, which is negative 1, 8. And then if I take the limit, the first one's going to give me 0. The second one going to give me 1 over e. So the limit is going to be 1 over 8e. For example 2, we want to determine whether this series is convergence or divergence. So hopefully you can see that this series is going to be from 1 to infinity, 1 over n square root of n. So if I rewrite, I rewrite and change the square root into exponent, um, fractional exponent. So I get n to the 3 second power. So this is a p series with p is 3/2. And 3/2 is greater than 1. Therefore, we know that this series is convergent. We want to determine whether the series convergence or divergence. I'm going to use the integral test, but before I do that, I have to check the function. So the function that we have is x to the 7 over x to the 16 plus 1. So we can see that this is positive on the interval from 1 to infinity. It's continuous. And the last thing we have to check is decreasing. Now, if I need to check for decreasing function, I'm going to go to the f prime function. So for the f prime functions, this one right here, we're gonna use the quotient rule. So I'm gonna take the quotient rule, and I ended up with 7x to the 22nd plus 7x to the 6th power minus 16 x to the 22nd over x to the 16 plus 1 squared. So if I rewrite the function, I'm going to end it up with 7 x to the 6 minus 9 x to the 22nd over the denominator. So let's take x to the 6, let's factor out x to the 6th power. I ended up with 7 minus 9 x to the 16 over x to the 16 plus 1 squared. You can see right here that the function is negative on the interval from 1 to infinity. Therefore, it's decreasing. Now we're going to apply the integral test. So for the integral test, we have from 1 to infinity, taking the integral of x to the 7 over x to the 16 plus 1 dx. So we're going to have to take the limit as t goes to infinity. All right, I'm going to rewrite the functions a little bit. So hopefully you can recognize that this is the arctangent. So x to the 8 squared dx. If you're using my cheat sheet, you will see that this is just arctangent. So I have t goes to infinity. I take out 1/8. Arctangent of x to the 8 power. And we want to evaluate from 1 to t. So what I have is 1/8 limit t goes to infinity. The arctangent of t to the 8 power minus arctangent of 1. So you can see that we have pi over 2 minus pi over 4, which is pi over 4 times 1/8 outside, so it's going to be pi over 32. So the series is convergent.